Let's take a look at problem largest product. And we have over here, it's in module 5. And so the concept behind here is you have a total of 1,000 digits. And you have to find, so the example is that if you have 4 adjacent digits in the 1,000 digit number, you have to find the one that gives you the largest product. Here it is, right? So somewhere in there, you have a 9989 together. But the question is, find the 13 adjacent digits in the 1,000 digit number that have the greatest product. So I have right here some ideas on how to do this. So conceptually, you need a for loop that is going to actually move through 13 digits at a time. So for example, you will take the first 13 over here, the next 13, and you will be saving that information to a variable. And as usual, you want to have something that is, I don't know, let's say, what was it called? Largest product. So we can say something like largest over there, right? We can say largest, right? I start with a 1, right? Let's say, doesn't look too good, right? But ideally, what I really want to do is, let me put this down a little bit because I need a space over here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 here. Here you have 13 digits. So you want to find the product of all this, right? What's the product? And if you had a variable, like I said before, largest, let's say, equals to 1, then this new product, you can compare it to largest. And obviously, if it's larger than 1, in this case, then you go into, and you can make it 0 too. So you can say if, the typical thing, and I think that's what I have of it. Do I have that over here? Let's take a look. I don't have that part, right? But the usual, when you have a new large value, then you want to swap it with whatever value was holding that variable before. That is always the most current largest value. So, I mean, in terms of that, I mean, it's typical to have an if statement in which you say, if the product, is largest than this variable that I'm keeping to hold on to the last or the most current or the largest of all the current large values, then I'm going to swap them, right? So I'm going to say that then largest is equal to product. So this is the part that definitely, I think you've seen that before. So the next part would be then, so how do we move across? We have to go across the whole 1,000 digits. So the next thing will be then, let me erase this so I can have a little space to show the actual motion of the mechanics or the, what's it called? The dynamics of it, the mechanics behind it. So, so we came up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So we calculated the first 13. And we have a product over there. And then we move up by 1. And so I'm going to do the next 13. So this will be the next one over here. Obviously, there is a 0 over here. I mean, if you wanted to improve the efficiency, it's like as soon as any integer is equal to 0, you don't have to bother with doing the calculation. But at this point, we don't want to get into those little details. So that means that I am incrementing the position of my for loop by 1. What for loop? Well, we have to have 2 for loops. We have 2 machines over here. One that actually does the inner calculation of this, right? And the other one that keeps track of the next digit that I'm moving to start counting 13 from there. So technically it looks to me that you have two for loops, two nested for loops. So you have for I equals to, and you can start from 0, right? And then you go all the way to um, I will be less than 13 because you start at 0. So that would be the inner loop, right? But then we need the outer loop, the one that, so this one is the one that does the product. Here you calculate the product. The product of those 13 digits. Then I need another for loop, an outer for loop that is going to be going from, let's use j equals to 0, right? And it will go all the way to j. So where would you go up to? Because remember, you need to take 13 digits, last 13 digits, right? So it would have to be less than the length over here of this 1000. And don't use the number 1000 because we call that magic numbers, meaning what do they mean? Where they come from? They don't have an explanation to them. That's one thing. And the other one is, let's say when you reuse the program for something else, instead of 1000 digits, you have less or more. So if you had it somewhere assigned that value, then you can change it in one place, no matter how many places else you use it. So I'm going to, whatever you want to call it, I'm going to say that that would be the length of these 1000 digits, right? Minus, I guess, 13 of them, because we want the last 13 of them. So you might want to tweak a little bit this, make sure that this is it's not going to give you a index out of bound error. And then the next thing is that this j is going to be moving by one at a time up to that point, right? So from here, right, now you say, I cannot be 0 anymore because I0 always will be just these 3 over here, this 13 over here. I now becomes a little bit more dynamic. It has to be moving along with whatever j is. So the beginning of j, let's say, and let's start from, let's do a little tracing. Okay, let me get this out of here, right? Because we don't need it. And let's do a little tracing over here to understand how this works. So that lags a little bit. So I'm going to say that j is going to start with 0. And right here is the 7, right? Here's 0. And then you're going to take from whatever j has, right? In this case, it's going to be, instead of having a 0 now, I am going to replace this with whatever j is. Because j is the one that is going to be moving along those 1000 digits. And I is going to take from wherever j starts up to 13 of those digits. And so you're always going to be taking only 13 of them. And then you're going to have this product over here. And that product is the one that you want to compare to, let's say, the other variable that's largest. By the time you finish all of this, then largest will hold on to the one that is the product of those 30 digits that, as a result, they give you the largest value. I hope this helps.